Welcome to course of lesson 15 classification. So in last lesson we have learned about a regression, that was a specific kind of a problem, and now we are going to learn about classification. So we are going to learn first what is classification, what are the different kind of algorithms are there, how to build a model in classification problem, and how to evaluate that. So this would be a high level introduction to classification, and then we will take one by one. So in this classification algorithm we would expand. So we would learn logistic regression, KNN, SVM, decision tree, random forest, all those part. So let's learn what is classification. So I hope you are already familiar with this picture. So whenever I discuss that what is regression, so wherever you have a dependent variable and you have to predict the dependent variable, that is supervised learning, right? Now in supervised learning also, either the dependent variable can be numerical or it can be a categorical one. So if it is a numerical, like you are trying to predict rainfall, you are trying to predict sales, you are trying to predict your life expectancy, those are numerical in nature. That's why those are regression. But if you are trying to predict whether this is a cancer or not, or your customer would leave you or not, whether this image is for cat or dog, all those, or whether this transaction is fraud or not, all these are, if you see, those are yes no kind of problem statement. In those kind of problem statement we call a classification, and we have to come up with a classifier, which is nothing but I need some algorithm which can classify all the transaction to fraud or not fraud. So it can be written as a 0 1 or it can be written as a yes no, but basically from the dependent variable you can identify what kind of problem is this, whether this is a regression or a classification. And once you identify this is a classification, then you have to apply different kind of algorithm, which we would be discussing in our next lesson. So as I explained, unlike regression where you predict a continuous number, you use classification to predict a category. And there is a wide variety of classification application from medicine to marketing, and all the time your response variable would be qualitative. So response variable is nothing but your dependent variable, which can be either in terms of yes or no, or it can be a 0 1. So if you try to predict a qualitative variable, then you would see this credit approval. Should I give a loan or not? So your dependent variable would be yes or no. Fraud detection. Is the transaction fraudulent or not? Yes or no. Medical diagnosis, cancer or not? Yes or no. So these are standard use case of classification, but I'm sure you would be finding a lot more than this. Now let's talk about the algorithm. Now predominantly we have two different kind of classifier, which one is linear, another one is non-linear. So what do I mean by that? So suppose you are trying to understand whether your customer would take some offer or not, and you have two variables. Suppose one variable is age, another one is salary. So suppose you are working for Myntra.com and you have planned for a new offer, and then you are trying to understand whether someone would take this offer or not. So you need to have historical data, historical pattern you need to have, and based on the historical pattern you have understood that most of the people whose age is less but salary is low, they are not going to take it. But those people whose age is low but salary is high, they are going to take it probably. Okay, something here. So what you would do ideally, you would try to create a plot or a linear line which can distinguish these two. So suppose you create a line like this, so that you can say all these people falling left side of this, they are not going to take it, and all the customer who are right side of this line, they are going to take this offer. So what exactly we are going to do? We are going to train our model from the past historical data, and based on that we are trying to find a perfect linear line which can probably divide the whole data set into two things, yes, no, 0, 1, that kind of things. Though these are linear model. But suppose you have exact same problem statement, but you are not fortunate enough, there is no linear line which you can probably create. Rather you feel that a non-linear line is a perfect fit. So suppose again you have few people here, but again once the age is high, even if your salary is low, still people are taking it. And then you have again people who are rich, age is low, and again probably you have people here, though they have money but they don't want to take it because this is probably for young age. So what you do, if you try to create a linear line, probably it would fail. But if you come up with a non-linear line, probably that would be a perfect match for this. So you can go like this. So suppose let me create couple of other line here, okay, and then probably if you can come up with a line like this, then probably you can divide the whole data set into two different category. But see, this is non-linear in nature, it's not a linear one. That's why we are talking about we have non-linear model. So we need to learn both the things, linear as well as non-linear. First you can try with logistic regression. If you find a line and if you find good accuracy of your model, that's perfectly fine. But if you don't find that kind of line, then you have to try with this kind of non-linear line where probably you would get better accuracy. And we are going to learn each of these things one by one. So as I said, classification models include linear models like logistic regression SVM and non-linear like KNN, kernel SVM, random forest, and all those different algorithms. Now high level, try to understand how normally it happens. So remember that graphical picture in your mind, that all we are trying to do is trying to create a line which can divide the whole data set into two category. Now every time I'm talking about two category because this is yes or no, 0 or 1, but this classifier can actually predict more than two. So I'm not taking that name because it's very difficult to draw, but try to understand if you have three level, that also you can do. So you can divide it into high, medium, low, that kind of thing also you can do, which we would discuss later. But at this point of time, just focus on two level, that your dependent variable has two level, yes, no, or 0, 1. Now let's take an example. Suppose what you are trying to understand, you are trying to understand whether your some professor is tenured or not. So based on these three variables, so you have name, you have rank, and you have years. Now this is your training data set. Now in earlier days, if you had to create a classifier, what you would do, you would simply write some if else statement, right? So similar to that, let's try to see what is the logic which can best fitted for this data. So I can see that if the rank is professor, then also this is yes, and if it is assistant professor but more than 6 years of experience like this, then also we can call it tenure. So this is the logic I have created. So this logic is nothing but a classifier or nothing but a line, okay, which can divide all your data set into two different parts. So again I am summarizing. So how to create a model construction? So model is nothing, I mean, from your historical data set, we are trying to come up with a logic, or we are trying to come up with a classifier which can divide the whole data set into two different categories. Once this is done, let me show you. Then model evaluation. Now, since you have already created this classifier or this equation, how do you evaluate? So you can divide your total data set into train and test. If you see, this is testing data set and the names are different: Joseph, Tom, George, which is not there here, right? So how would you get the test data set? So suppose if your total job is 10,000 transaction data set you have, suppose you have 10,000 data set transaction data, and you want to understand whether this is fraudulent or not. So what you would do, you would divide it probably 80-20%. Probably you can say that 8,000 I would keep is as train data set and 2K as your test data set. Okay, this is traced and this is your train. Now you train your model here with this 8,000 data set. You would train your model, and then on top of these 2K data set which is unseen. So I haven't trained my data with this test data set so that I can really understand that how my model is performing on an unseen data, on a test data set. Okay, then I would try to test my model with this test data set, and I would see what is the accuracy for each of those algorithms. So with the same concept, we have test data set, and now on top of this test data set I am trying to predict. Okay, so suppose you already have this tenured, but suppose I am trying to predict. So if you remember our earlier logic, what did I say? If it is professor, then I would say yes, and if it is assistant professor but greater than 6, then also I would call them yes. So I would call them yes, I would call them yes, and this is obviously no. So this is my prediction. This is my prediction. But when you actually compare with actual, this is actual, then you would see probably my prediction is not correct all the time. So this is a case where my prediction is not correct. So based on my earlier equation, or based on my earlier classifier, it should have been yes. But yeah, that's machine learning. Always you would not get 100% accuracy, but still I can say 3 out of 4 I have predicted correctly. So I can say my accuracy is like 75%. So we would be doing a lot of example with this, but very high level try to understand what exactly we did. So we first had data which we divided into training and test data set, and from the training data set we tried to learn how to identify, how to predict this tenured, and we created a classifier which is nothing but a equation, and from that equation we said if the rank is professor or year is more than 6, then it's a tenured one. Okay, and based on that classifier, when we are testing our model on the test data set, we tried to predict, but obviously it may not be 100%. So we got a model which can predict 75% accurately. So this was high level classification algorithm, how it works, what are the different kind of algorithm we had. Now we will take one by one. So first we will start with logistic regression.